Hey genius, welcome to Easy Way Math. I am Samiksha. Today we will discuss nth derivative of standard function. There are 9 standard functions. Let's see one by one. So our first function is y is equal to e raised to ax. We have to differentiate with respect to x. Then we will get y1 is equal to a into e raised to ax. The x coefficient is a, so our answer is a into e raised to ax. Again, we will name it as a 1. Again, differentiate 1 with respect to x. Then we will get y2 is equal to a into this a will keep as it is, and the differentiation of e raised to ax is again a into e raised to ax. Then that will become a square into e raised to ax. Again we will name it as a 2, and again we will differentiate 2 with respect to x. Then we'll get y3 is equal to, we'll keep this a square as it is, and the differentiation of e raised to ax is again a into e raised to ax. Then our answer will be a cube into e raised to ax. By by observing the by observing these three results, we can conclude for yn, that is a raised to n into e raised to ax. Then this is the standard function of e raised to ax. We will move towards the second derivative, that is y is equal to a raised to m into x. Now we have formula for y is equal to a raised to x, that is equal to a raised to x into log a, and the x coefficient is 1, so we'll keep 1 as it is. Now we have to differentiate y is equal to a raised to mx, so y1 will be m into a raised to mx into log a m. We will moving towards y2 is equal to, we'll keep this m as it is and this log a as it is, and again differentiating a raised to m into x, that we will get a raised to mx into m log a. Then this can be also write as m into log a whole square into a raised to mx. We will find out for y3, that is we will keep m log a whole square as it is, and the differentiation of a raised to mx will be a raised to mx into m log a. This can be written as m into log a whole cube into a raised to mx. By observing these all results, we can find out yn is equal to m log a raised to n into a raised to mx. This is the nth derivative of a raised to mx. Now moving towards the third one, y is equal to ax plus b raised to m, where this is the tip where m should be positive and m is greater than n. If this we have the formula for x raised to m is equal to m into x raised to m minus 1. So now y1 is equal to m into ax plus b raised to m minus 1 into a. Now we will find y2 is equal to a into m. We will keep this both as it is. Then again this will become as a m minus 1 into a raised to x plus b raised to m minus 2 into 2. For y3 we will keep a square into m minus 1. Again we will differentiating ax plus b, then this will become ax plus m minus 2 into ax plus b raised to m minus 2 into a. Then this can be write as aq into m minus 1 m minus 2 and ax plus b raised to m minus 2. By observing these results we can write yn is equal to a raised to n into m minus 1 m minus 2 m minus 3 so on up to m minus n minus 1 into ax plus b raised to m minus 2. This will go on up to m minus n minus 1. As I already mentioned that m is always greater than n, that's why our nth derivative contains m minus n minus 1. I hope you understood this. I will be back next week with other standard functions of n derivative. Thanks for watching.